Hi, Warriors. So right now we are going through phase change notes, and right now we're going to start going through those questions. So let's start with question 1, identify the following. So for 1A, it asks you to locate the normal boiling point, and just so you know, normal boiling point takes place at 1 atm, or with this graph, it would be in kilopascals, so 101.3 kilopascals. So normal boiling point for this particular graph, normal boiling point for this particular graph would take place here at 101.3 kilopascals. And so go boiling, we know that this is going to be the line for boiling because it separates liquid and gas to boil liquid into a gas. So 101.3 at normal pressure. Our boiling point for this particular graph would be about 61 degrees Celsius. It would be the normal boiling point for this substance. So 1B asks us to now locate the normal melting point. Remember, normal melting point or boiling point takes place at 1 atm, or in this case, 101.3 kilopascals. And if we are melting, to melt goes from solid to liquid. So we're going to be going somewhere along this line here. So we want to start at 101.3 kilopascals, which would line us up right about here. Drop that down to the x-axis temperature, and that's roughly 24 degrees Celsius, and that would be the normal melting point for this particular substance on this graph. Let's look at question number 2. Estimate the following. So you are going to estimate the boiling point when the pressure is 60 kilopascals. And so all you're going to do is find 60 kilopascals, and you need to determine which one of these 3 lines is boiling. If we're going from solid to liquid, that's melting, but liquid to gas is boiling. So we want to be somewhere on this line. And so 60 kilopascals, go ahead and carry that over. It's about right there. Drop down to the x-axis, and we have about 51 degrees Celsius. So keep in mind, everybody's is going to be a little bit different because we're just estimating, and this isn't the most accurate graph, so that's okay. We are just interpolating data right now. We're using the graph to land on a line, interpolating data. Okay, so 2B asks us to estimate the melting point when the pressure is 80 kilopascals. Again, we know that from here, melting is solid to liquid, so we're going to be somewhere on this line. If we're at 80 kilopascals, we want to follow that line over to our melt line, and then drop down to the temperature, which is about 21 degrees Celsius, the melting point for this substance at 80 kilopascals. Question 2C asks us to estimate the sublimation point when the pressure is 32 kilopascals. Okay, so again, sublimation, that is going from solid to gas. It's very unusual. It's like dry ice sublimation to sublime. So we're going from solid to gas, and we're going to be at 32 kilopascals, which is about here. So I'm going to go ahead and follow that line until I hit the sublimation line, and then drop down to the x-axis, and I get approximately 9 degrees Celsius. You've got something a little bit higher or a little bit lower. That's okay. Remember, this is just an estimate. All right. So yes, about 9 degrees Celsius for the sublimation of this substance at 32 kilopascals. All right. Question number 3. Identify the phase, solid, liquid, or gas. If we're at 80 kilopascals and 5 degrees Celsius, so 80 kilopascals, 5 degrees Celsius, our point would land right about here. So that means we're in the solid phase. We're in the solid slice of the pie. All right, so let's take a look at a substance that's at 60 kilopascals and 40 degrees. So 60 degrees and 40 degrees, that hits us right in the liquid slice of the pie here. So this is going to be a substance at a liquid. It is a liquid. And then 3C, we're going to identify the phase at 20 kilopascals and 50 degrees. So we've got 20 kilopascals, and really I don't need to show this, but we can already see that 50 kilo or 50 degrees Celsius is hitting us right in the gas slice of the pie. So this would be a gaseous substance under those conditions.